here we are.
Breakfast for lunch today.
I'm having spaghetti casserole for lunch today. All right.
Spaghetti casserole.
So it's just the
Baked
spaghetti and the meat sauce all just thrown in together.
With like some cheese on top.
Probably
And then
not.
baked.
Yeah, it was baked.
Okay.
And
so
then
it's just spaghetti and meat sauce. That ain't a casserole spaghetti.
no, it was baked and yeah.
Noodles with your sauce.
Yeah. Okay. So back to calculus. So this is why calculus was invented, because they wanted to find the area under a curve, okay, because they needed it for various applications. So they figured out that if they use integrals, this is basically a summation from 2 to 6 over the curved surface of this curve, okay, that they put 7 billion, million, trillion tiny rectangles in here, it would make a curved surface and it would work out nicely, okay? So we had 4 rectangles and then we got it down to more and more and more and more. So how we do that? Well, we do limits to make that work, okay? So it's a limit as the function is happening. So we need the width of the function, the change in x, and then the x of the function, and then put that into the function. All right, you got one right. Okay, so the function was 1/5 x squared. So this winds up to be x from the summation. And then if you square the summation and take it times 1/5 over that area, you'll get the right answer. Okay? So what they did is they took 4 times 1 over 5n. So this part is there. This part is there. And summation from 1 to n, because we have n rectangles in there. Okay? So we're doing this for sine. Okay? So the sine from 0 to pi for the sine of x. So the sine curve from 0 to pi looks like this. Okay, if you remember your trig, because then it goes like that and so on. Okay, so you got to just imagine your rectangles here going up like that. So how wide is it? Well, to find our change in x, we go pi minus 0 divided by the number of rectangles. Well, how many rectangles do we have? We have n rectangles. Okay, so the width of this, each rectangle, is pi over n. What's the height of the rectangle? Okay, well, that constantly changes, doesn't it? Okay, so the height of it depends on the sine function. So the first rectangle would be I, and then we divide that by n. Okay, the second rectangle would be, or if it's I, so the first rectangle would be 1 divided by n. The second would be 2 divided, because if I is 1, and then it'd be 2, and then be 3, and so on and so forth. So here's your width. I over n is your function. So it's the sine of I over n times pi over n. Okay, because you wouldn't put the pi in front because that wouldn't make sense. Okay, all right, let's try one. So now we're working the other way because we went from here to here. Now we're going to go backwards and say, well, which function is this? Okay, so this is our width, right? So it equals something minus something over n. Well, something minus something is going to leave us with pi over 2. Okay? What leaves us with pi over 2? Well, pi over 2 minus 0 does, or 3 pi over 4 minus pi over 4 does. This does not, this does not. So it's either this one or this one. Okay? Now, it's, where do we start out at? We start out at pi over 4, and then we go up by pi over 2. Okay? So if we start out at pi over 4 and go up by pi over 2, it must be this one. Okay? This one's like our first one that we had with sine. Okay? So, is that all my examples? I should have another example, but I guess. So, how far did we go? What's our change in x? Well, our change in x is pi minus 0 over n, or it's pi over n. So it has to be a pi over n, so it cannot be that one, cannot be that one. And as most of you did your homework last time, you got it down to a 50% chance and you guessed from there. Okay? And then because pi should not go in here, it must be this one. Okay? So, do your best on this. If you have some problems from the last one that you need to finish up, do your best on that. And then we have a little quiz to take over this last 3, 4, 7.